multiplying and dividing algebraic fractions. We're going to go back to looking at the difference, not the difference, we're going to look at normal fractions, and then we're going to see how the algebraic fractions correspond to that. Again, the rules are all the same. I'm happy we get the chance to do some of this again, because I remember some of you messed up the multiplication and division. So when I have a normal fraction, it can be anything like, let's say, 3/6 multiplied by 2/9. And the rule is, if I multiply fractions, I multiply the numerator with the numerator and the denominator with the denominator. However, before I do that, because I always have to have my answer in simplest form, I simplify before I multiply. That's the closest I'm going to get to poetry. So simplify before you multiply. What do I mean? First, see if you can divide anything into anything. In other words, does 3 divide into anything underneath the line? Because you don't have to do this, but you can actually rewrite this as 3 times 2 over 6 times 9. And you can say that 3 times 2 is 6, and 6 times 9 is 54. But it's harder to simplify this than just to simplify from this position. Okay, so if you leave your answer like this, you're going to lose marks. So what we do is we simplify before we multiply. We say, can 3 go into anything? Yes, 3 can go himself once, and then 6 twice. And 2 go himself once, and 2 goes divide into 2 once. So my answer will be 1 times 1 is 1, and 1 times 9 is 9, so the answer is 1/9. That will be the answer. Okay, so let's look at algebraic fractions. Algebraic fractions can be something like 4x over 7 multiplied by 2y over 8. Okay, what we're going to do now is, let's make that a 3. Ugliest 3 ever. That's a 3y over 8. So what I'm going to say is this is actually going to be numerator with a numerator, denominator with a denominator. In other words, 4x times 3y over 7 times 8. But I'm going to simplify before I multiply. 4 is, can 4 divide into anything at the line? Is there a highest common factor? There is. 4 divided itself is once. 8 divided by 4 is 2. 3 cannot divide into anything, and 2 cannot divide. So that is as simple as it's going to get. And all I'm going to do now is I'm going to say 1x times 3y. 1 times 3 is 3. X times y is x. Y divided by 7 times 2 is 14. And that's my algebraic fractions. So algebraic fractions, fractions with thingamabobs in there, with binumerals in them. Let's have a quick look at division. Now the thing with division is, here you cannot really simplify before you multiply. The first step is to change a division into a multiplication. 4 over 5 divide by, let's say, 3 over 4. Biggest mistake, people say 4 go himself once, 4 go himself once, and that is wrong. Okay, so the first step is we're going to change the division into multiplication by taking the second fraction and multiplying by its reciprocal. Okay, so reciprocal, big word. Reciprocal. Right, the reciprocal is if this reciprocal of 3 over 4 is, this thing just swaps around, it becomes 4 over. Reciprocal is when it is swapped around. So this division becomes multiplication, and this, the reciprocal of 3 over 4 is 4 over 3. Now I have a multiplication. Now we go back to this rule, and now I simplify before I multiply. Anything above the line, does it simplify with anything underneath the line? Nah, so I can say 4 times 4 is 16, 5 times 3 is 15. My answer is 16 over 15. I don't have to simplify anything. That's the answer, and it's in simplest form. Okay. Let us look at algebraic fractions. I have 2x over 5 divided by 3y over 7. First step is I change my division to multiplication. 2x over 5, and then this thing becomes a multiplication by reciprocating that. Oh, I think I just made up a word. So that equals, anything before I multiply, I simplify. Any numbers that can simplify, any x's and y's and pronumerals that can simplify, it appears not. So I say 2 times 7 is 14x, 5 times 3 is 15y, and that is as simple as it gets. And that's your final answer.